So now for example number 5, we're going to be given the complex number z, which is equal to 1 minus 2i, and we're told that's a 0 of the function f of x is equal to 4x to the 4th plus 17x squared plus 14x plus 65. Okay? Does that make sense? Now, what do we know about complex numbers? Do you guys remember what I told you yesterday? What do you remember about that? They travel in, you can look at my whiteboard, it says right on the whiteboard. Complex numbers travel in pairs, and what is the pair? The other, they're twin. What's the fancy word, though? Yeah, it is an opposite, but what's the fancy word? The reciprocal. So now, what that means is, if this is a solution, then there's another solution of 1 plus 2i. Okay? So now here's what we're going to do. What they want us to do is they want us to find, they're saying that it's possible that this has every single one of these solutions is complex. Which I kind of see because it has a vertical shift of 65. So what are the odds of something with a vertical shift of 65 crossing the x-axis? Not very likely, right? So that means it probably doesn't cross the x-axis, but maybe once or twice. Well, wait a minute. It's an even function, so it comes in from the top, goes out the top. It's been shifted up 65 units. It probably doesn't cross the x-axis at all. You guys understand what I'm saying? So let's graph this. I want to graph it so you guys can understand, because a lot of times I just kind of rattle off stuff, and you're like, huh, what? Here's what I want to show you. An even-powered polynomial. Whoops, I got to make it. That's what that looks like. Okay? It's an even-powered. It comes in from the top, goes out the top. Now watch out what happens as I add each term. When I say plus 17x, okay, raised to the 2, see how it changes the graph a little bit? Then when I say plus 14x, right, changes it a little more, makes it kind of looks like a parabola. Now watch what happens when I hit plus 6, shifts it up a little bit, but when I say 65, we can't even see it on the graph. So that means it's way, way up here. It's been shifted up 65 units. So I'm going to have to get to the 60s before I even get close. So clearly there's no real x-intercept or no real solutions. Does that make sense to you guys? Okay, so now what we're asked to do is we're asked to find the complex solutions. Uh-oh. That seems difficult. But you know what? We do the same thing that we've done before. We're going to do synthetic division. And we're going to list our x to the 4th, x to the 3rd, x squared, x, and then x to the 0. Well, I have 4x to the 4th. Oh, wait a minute. I don't have an x cubed term. What's a number that represents don't have 0? So I just put a 0 here. And then this becomes 17, this becomes 14, and this becomes 65. Now here's the weird thing. You do it exactly the same way. So I drop the 4 down. But now when I multiply 1 minus 2i times 4, shouldn't I get 4 minus 8i? Because you got to distribute that through. I'll let it soak in. Does that make sense to you guys? Does anybody have any questions about what I've done there? I'll write it down real quick so you can see. This comes from 4 times 1 minus 2i. So when you distribute the 4 through, you get 4 minus 8i. You guys see that? Okay, you don't need me to write that down, do you? Okay. All right, so now I drop that down. All right, cool. Now I've got to multiply this by this again. Now this is where it gets a little tricky. If I say 1 minus 2I times 4 minus 8I, I'm going to have 4 minus 8I plus 8I minus 16I. The 8i's cancel and I get 4 minus 16I. You guys see that? So now when I add these up, this is again where it gets a little... Oh, wait a minute. I think I screwed up there. 4, let me do that again. 4, I definitely screwed up. 4 minus 8I times 1 minus 2I is 4 minus 8I minus 8I 16I. Oh, it's the I. Okay, thank you. Okay, so yeah, I definitely screwed up. So okay, I see what I did. So now I thought it was negative. It's because I forgot the sign. So this is really 4 minus 16I and then plus 16I squared. But what is I squared? I squared is the same as negative 1. So I really have 4 minus 16I minus 16, or negative 12 minus 16I. Gotta be careful there and take our time, make sure we know what we're doing, which is why we should be in courtesy mode paying attention, right? Because this is complicated. It's complex. Like that. See what I did there? All right, so I'll try not to make any more mistakes. So now what is the 17? What is that? That's a real number. And then I have a complex number. So how do I combine those? You can think of this as 17 plus 0I is how you could think of it, right? So I'm just going to combine the real numbers, and that's going to be 5 minus 16I. Whew, this is a lot of work. So then I'm going to say 5 minus 16I times 1 minus 2I, and I get 5 minus 16I minus 10I, and then I'm going to get positive 32I squared. But what's I squared? Negative 1. So I'm just going to make that negative 32. You guys see that? All right. So that becomes negative 27 minus 26I. I'm running out of room here, so I'm going to write my 65 way over here. Does that make sense to you guys? So now what I need to do is I need to combine like terms again, and I get negative 13 minus 26I and I'm going to multiply that by 65. Or multiply it by this. So I'm going to say negative 13 minus 26I times 1 minus 2I. And I get negative 13 minus 26I, positive 26I, and then 2 times 26. So this is a positive 52, but then when you have the I squared, it's minus 52, right? Those do cancel this time, and I get negative 65. So over here I get negative 65, and my remainder is 0. Okay? So we're doing it just like we did before, and I'm gonna change some of these. I'm gonna erase some of these and make a little room. Because that's a little crowded in there. So I'm going to have 5 minus 16I, and then over here I'm going to have negative 13 minus 26i, and then 0 is my remainder. So now this is x to the third, this is x squared, this is x, and then this is like my constant. So I've got all these terms here, okay? And that's kind of how I could think of it. You guys with me so far? Now what did I say was another possible solution? Well, the conjugate. So now I'm going to hit the same thing with 1 plus 2i. Alright, let's try it again. I'm going to drop this down and I'm going to say 4. Now for time's sake, I'm not going to FOIL everything out, or do you want me to FOIL everything out? Should I FOIL everything out? Just know that if I multiply this by 4, I actually get 8, or 4 plus 8i. So when I add up the real components, I get 8. Okay. Now when I multiply this by 8, I get 8 plus 16i. And so when I add up the real components there, I get positive 13. And then 13 times this is just going to be 13 plus 26i. And so I get a remainder of 0. So now everything drops down 1 power and I get 4x squared plus 8x plus 13. So what I've done is I've taken this function, and let's rewrite the function so you guys can see it clearly. I've taken the function f of x, which is equal to 4x to the 4th plus 17x squared plus 14x plus 65, and I found many of the factors, but we're still not quite done. And I found that these two are factors, and I've broken it down, and we're almost done. So I got to take this last one, and usually what we do is we factor until we get to a quadratic equation, and then we solve by using the quadratic formula. So the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. What's this ABC stuff, Mr. Adams? Well, it's ax squared plus bx plus c. Okay? So to do this properly, I'm going to say x is equal to minus b, but b is 8, plus or minus the square root of b squared, which is 8 squared, minus 4 times a, which is 4, times c, which is 13, all over 2 times a, which is 4. You guys with me so far on this? This is where it's going to be fun. So on the next line, I've got x is equal to negative 8 plus or minus the square root of negative 144 all over 8. Well, that's not good, is it? So that means... Can we take the square root of a negative number? Nope. It's a little bit of a problem, isn't it? So then what I'm going to do is I'm going to say x is equal to minus 8. What's the square root of 144, though? 12. So what do I write here, then? Yeah, it's... Remember that we could change this 144, the negative 144. Isn't that the same as the square root of negative 1? Or wait, let me write it around another way. Isn't that the same as the square root of 144 times the square root of negative 1? Yep. And remember that the square root of negative 1 is just I. So this becomes 12i, all over 8. Now, you could reduce that. I could say that this is equal to negative 8 over 8 plus or minus 12i over 8, which reduces down to negative 1 plus or minus 3 over 2i, which means x is equal to -1 plus 3/2 I, and x is equal to -1 minus 3/2 I. Remember Mr. Adams said the complex numbers always travel in conjugates? So now what have we done? Man, that's a lot of work. Can you keep track? Somebody tell me what we've actually done. I'll get you started. We started with the original function, which was 4x to the 4th plus 17x squared plus 14x plus 65. And then what did I just figure out in all this work that I've done? Huh? I figured out that this is equal to x, right? I figured out this is equal to x plus well, actually it's x minus the quantity 1 minus 2i times x minus the quantity 1 plus 2i, x minus the quantity -1 minus 3/2 I times the quantity x plus -1 minus or plus 3/2 I. Man, I ran out of room, didn't I? Well, anyways, if you push all those negatives through, no, I gotta write it down that way. It's really difficult, but it is. So let's write it down again. I'll just make a little more room. X minus 1 minus 2i, x minus 1 plus 2i times x minus -1 plus 3/2 I times x minus -1 minus 3/2 I. Those are the zeros of that function. Now, does anybody have any questions about that? Now, if you wanted to, you could distribute the negative signs through the parentheses and you'll get something else. Now, the only other issue for that is that there was, we have to do things a little differently, is that you have to put in like the leading coefficient. Okay? And so the 4 zeros then, those are the zeros. Because the leading coefficient was 4, we do have to tack that 4 on the beginning. Okay. And then there's some things you could do to remove the fractions if you wanted to multiply it by something, but that's it right there. Are there any questions? Okay.